Okay, so far what we were dealing with was the problem of the form maximizing C transpose X subject to the constraints Ax equal to B, X greater than or equal to 0, right? So for two variable problems, we have graphical method, right? Okay, but when the number of variables are greater than say 3, so we cannot solve this problem by graphical method. So graphical method does not work. Even for 3 if the variables are 3, we are in 3-dimensional space, so graphical method is little difficult to apply with. So but when the variables are strictly greater than 3, I mean we are in 4-dimensional space, so we cannot actually see what things are happening. So graphical method does not work for the variables when it is greater than 3. Okay, so graphical method does not work. Then what we had was the simplex method. Okay, so what simplex method was dealing, so so what we are doing in simplex method is we are calculating what we initially understand what the relation between corner points between corner points and BFS, and also we analyzed that one of the BFS is giving us the optimal solution, of the given LPP. Say I call optimal solution of the problem P. So if I call this as my problem P, right? Provided the optimal solution exists, right? Provided the optimal solution exists. Okay, so then what we are dealing with was, then our own objective was to hunt for basic feasible solutions, right? And in our program, what we did, we calculated all the basic feasible solutions, right? And then we figured out that out of all those basic feasible solutions, we were able to find that the one which is giving the maximum value is optimal. Okay, so calculating, then again we discussed calculating all basic feasible solution is not an easy task, or in fact sometimes impossible. So that was the reason that we need to look for an algorithm that gave us the optimal solution, and without calculating the basic feasible solutions, all the basic feasible solutions. Okay, so in order to understand that if we are not calculating all the basic feasible solutions, we have to miss many of the basic feasible solution. So we had our simplex method. So next we have our simplex method. Okay, simplex method, okay, it does not calculate or evaluate or say find, whatever you write, it does not evaluate all basic feasible solutions. Okay, so in order, since it is not evaluating all basic feasible solutions, so we tend to miss many of the basic feasible solution with the well defined algorithm. Okay, what this algorithm says, that you start with one of the basic feasible solution, and you look for the directions adjacent basic feasible solution in such a way that your objective function value improves, and you move towards that basic feasible solution in which you have a higher value of objective function, and you keep on doing this until you are at a position that no more improvement is possible, and we declare that basic feasible solution is optimal. Okay, for that we discussed some problems, right, to calculate the basic feasible solution. So one more problem we are going to try, and today's problem is with is the ready mix problem we discussed, right? Ready mix company problem, which I told you that we are not solving at that moment, which when we were formulating the problem. So what was that problem? It says that you have to maximize the total revenue 5x1 plus 4x2 subject to the constraints 6x1 plus 4x2 less than or equal to 24, then x1 plus 2x2 less than or equal to 6, then minus x1 plus x2 less than or equal to 1, and x2 less than or equal to 2. Okay, so this is my problem. So again, today's lecture will be like a revision kind of lecture, which we for solving the problem with the simplex method, which we were doing in my previous two lectures also. Okay, so I want you to be very careful, and if you have any problem, you can always interrupt me and ask in between, no problem at all, but try to listen first. Okay, so what we are going to do is, we are given a problem. So our first task is to convert this problem into standard form. So my first task is to convert the problem in standard form. Okay, so what is my standard form? You write it down like, so you have maximize 5x1 plus 4x2 subject to constraints what, 6x1 plus 4x2 plus one slack variable s1, so that will make it a equality constraints, and then x1 plus 2x2 plus another variable will make it as again equality constraint x1 plus x2, again I am adding one more variable, plus s3 equal to 1, and then x2 plus s4 equal to 2. Now I have my variables x1, x2, s1, s2, s3, s4 all greater than or equal to 0. Okay, and all these slack variables, they also have to contribute 0 value in the objective function. Okay, plus 0 s4. And from this standard form, we can extract our matrix A. So what is my A matrix then? So A matrix is the coefficient matrix. So you write down the coefficients of the first variable x1. What is that? 6, 4, 6, 1. It is 6. It is 6, 1, minus 1, 0, because in last constraint there is no coefficient of x1. In the second constraint, second variable is x2, 4, 2, 1, 1, and then third variable is s1, that is 1, 0, 0, 0. The fourth variable is s2, this is 0, 1, 0, 0. You have to be very careful while writing this matrix, because sometimes students mix up with the variable. So every column corresponds to one variable. So this first column corresponds to x1, x2, s1, s2. Similarly for s3, what is my variable? It is 0, 0, 1, 0, and then for s4 it is 0, 0, 0, 1. Okay, and what is my right hand side vector again? B vector is what? It is 24, 6, 1, 2. This is the data that we input initially. You need not mention when you are solving the problem by hand. Okay, so now we have to solve this problem by simplex method. We cannot evaluate all the basic feasible solutions, because we see, if you are going for algebraic method, which we call as evaluating all basic feasible solution, so maximum number of basic solutions are how many? 64. Okay, you can always see what is this value 64. It is really high value, around probably uh, 30. I think it's 30. 30 by 2, 15. So you have to evaluate 15 basic solutions. But I don't want to evaluate all the 15 basic solutions. So I want to have an efficient way that in the lesser number of basic solutions that I evaluate and I get to my optimal solutions. That's what I'm looking for. Okay. So what we do in this case, we first construct a table, construct a simplex table. Okay, so for to construct this simplex table, what I need, I need to have a feasible basis. Now what do I mean by the feasible basis? Means I should make a choice of the basic variables such that it give me a basic feasible solution, not the infeasible solution. You have already seen in your program that sometimes we are getting infeasible solutions also, that we are not interested in. Why? Because all my variables are greater than or equal to 0. Okay, so how can I guarantee with my given choice that this is a feasible basis? So you can see, out of 6 variables, I need to choose 4 variables in the basis. Why? Because number of constraints is equal to 4, and this is equal to what? The rank of A. Okay, so number of variables in the basis are what? So number of variables in the basis are how much? 4 variables. Okay, so 4 variables. So that means I need to choose 4 variables to construct my basis, first basic feasible solution. But the question is, which 4 variables out of given 6 I should choose, so that I have a basic feasible solution. Okay,
So can you explain?
yes, this is the point. So that means I need I need to choose 4 variables to construct my basis. Why? Because rank of the matrix is 4. You can easily see that I have a sub matrix whose determinant is always non-zero. Okay, I can see at a quick glance. But my question is, which 4 variables I should choose? So I need to construct a basis matrix with the 4 variables. Now question is, which 4 I should put? X1, X2, S1, S2. So होता क्या है कि when you choose these 4 variables, so you need to calculate B inverse B, and B inverse B should be greater than or equal to 0. Okay, so that means I need to choose those 4 variables for which my B inverse B is greater than or equal to 0. Now it is very
Yes, so
difficult. Now
yes.
it is very difficult to see ki, suppose I choose x1, x2, s1, s2. How can I foresee that its inverse when multiplied with the right hand side is always giving me non-zero value? So this is a difficult question to decide about my first basic solution, because I see once I have a basic solution, I can construct my simplex table, and then I can move on from one simplex table to another simplex table, maintaining my feasibility. फिर कोई problem नहीं थी. But constructing first is difficult. But in the present problem, there is no issue, right? So you see, uh, in the present problem, there is no problem in choosing basic variables, as one can see an identity matrix of order 4 in in the in the in the matrix A. So I should say identity submatrix, right? Because I need to choose 4 variables. So you see here in A, I can always see that I have a identity matrix of what, of comprising of these 4 variables. So if I choose B as my S1, S2, S3, S4, so my B matrix actually becomes what? It becomes identity matrix, right? And you see what is my B inverse? So B inverse is equal to B is equal to identity matrix. So I immediately find the inverse because I have an identity matrix inside the matrix A. Okay, and because identity matrix is there, I can always guarantee that when this identity, so I should say that B inverse multiplied with B is what? Identity multiplied with B. And what is that? You can see it is 1 0 0 0 0 1 0 0 0 0 1 0 0 0 0 1, because inverse is the same matrix. And when you multiply with the right hand side, what is that? That is 24 6 1 and 2. So what you get? You will get the same answer, that is 24 6 1 and 2. Okay, so B inverse B is actually, and this is always non-negative quantity because each of the component is non-negative. So the point which I want to raise is that in order to initiate your simplex table or simplex method, you need to construct a basis, one basis, right? Whenever you have an identity matrix, right, in the given problem, you can always find a basis. Why? Because you collect all those variables which constitute the basis, constitute the identity matrix. So those variables make a basis whose inverse I always know, and I always know that B inverse B is non-negative. Why? Because right hand side is also non-negative quantity because it is in a standard form. Is this clear? So once I have my basis, I can initiate the problem. And you can see whenever I have a problem of the form less than type, okay, because if you look at the original problem was what? Less than type constraints. So whenever there are less than type constraints, we can add slack variables. And when we add slack variables, each slack variable generates a column which is a column of identity matrix. Okay, so we do not have any issue. So let's make our first simplex table with that. So what we are doing is we are going to construct this table with my,
एक्सक्यूज मी सर।
yes please.
सर अगर कोई ऐसा केस हो जिसमें ये आइडेंटिटी मैट्रिक्स ना
I
दिख
will
रही
be
हो,
I will be coming to them. I will be coming to them. Okay. So my basic variables are what? S1, S2, S3, S4. ना आइडेंटिटी हो वो चीज हम डिस्कस करेंगे, डिटेल में डिस्कस करेंगे। बट पहले ये बात समझनी बड़ी इंपॉर्टेंट है कि अगर आइडेंटिटी है तो हमारी प्रॉब्लम इनिशिएट होनी बहुत आसान हो जाती है। वी डू नॉट हैव एनी इशू। सो आइडेंटिटी जरूरी नहीं कि सिर्फ स्लैक वेरिएबल के कॉरेस्पॉन्डिंग हो सकता है कि मेरे कुछ और वेरिएबल्स ऐसे पड़े हों विच आर जनरेटिंग द आइडेंटिटी मैट्रिक्स। सो वंस यू हैव दैट मैट्रिक्स whose inverse you know, you always choose those variables in your basis and you can initiate the process. That's what I want to highlight here, right? So because my slack variables are in the identity matrix, and then because I have to calculate what my alpha j is. So alpha j is what? That is my B inverse AJ, because B inverse is an identity matrix. So this will come out to be equal to AJ. So that means B inverse multiplied with the columns of A will actually give the same column. So my first table is actually the same A matrix. Okay. So it is 6, 1, minus 1, 0. This is 6, 1, minus 1, 0. And then I will be having second column as, let me see, 4, 2, 1, 1. And the slack variables are 1 0 0 0 0 1 0 0 0 0 0 1, sorry, 0 0 1 0, then 0 0 0 1. And your right hand side is what? B matrix. That this is 24 6 1 and 2. Okay, so this is my solution which I call my basic feasible solution, right? And then I have to calculate my Zj minus Cj. because the cost coefficient of all the slack variables is 0. So Zj minus Cj is what? Cb multiplied with the first column. So that is 0 vector minus the cost of the variable x1. So the cost of variable x1 is what? 5. So you can write here 5, I think 5 4 0 0 0 0. So you see the objective function. What is 5 4 0 0 0 0? So I have written all the cost here. Okay. So my quantity here is minus 5 because Cb multiplied with second column. So what was my formula for Zj minus Cj? Again, it is Cb transpose into alpha j minus Cj, which is, again I am elaborating that it is Cb transpose multiplied with a B inverse Aj minus Cj. And we know that B inverse Aj is alpha j, so these columns are my B inverse Aj. So Cb multiplied by this column, so I am taking this product, which is 0 in this case, minus C1 is minus 5, minus 4, 0 0 0 0. And you see, for the maximization problem, so this because Z1 Zj minus Cj is not greater than or equal to 0 for all j. Okay, as you can see, as Z1 minus C1 is equal to minus 5, which is less than 0, and Z2 minus C2 is minus 4, which is also less than 0. So that means the present table is not optimal. Okay, the present table is not an optimal table, is not say depicting an optimal solution. So in order to find an optimal solution, so what we have to do? So we have to enter into the basis the variable whose Zj minus Cj is most negative. So what is the Zj minus Cj which is most negative? That is minus 5. So that means I have to enter the first variable into my basis. So I am entering it. So I'm highlighting this column. So this says that x1 will enter into the basis. Then which is the leaving variable? So in order to calculate my leaving variable, I have to calculate what? Minimum ratio. So what is my minimum ratio? So minimum ratio was, again, you have to calculate xbi upon alpha ij such that alpha ij is strictly positive. You see here. So jth column I have already selected. So j is what? J is 1 here because Z1 minus C1. So you say that j is equal to 1. So this kind of notations, they are useful when you are writing your program, right? So j is 1. So what is my alpha 1 I? Okay, or I should say alpha 1 is what? It is my column with what? It is 6 1 minus 1 0. You see, what is 6? 6 is my alpha 1 1. This is alpha 1 2. This is alpha 1 3, and this is alpha 1 4. Okay. Okay. So similarly, this 24 is my x b1, second x b2. This is my x b3, and this is my x b4. So these notations are very important to understand. Okay. So when I'm calculating this ratio, that means I'm calculating xb1 upon alpha 1 1. So what this ratio come out to be equal to? What is xb1 divided by alpha 1 1 is 6. So this is what? 24 by 6. And then 6 by 1. And then because this is negative, alpha 1 3 is negative. So I am not taking into account because my condition is that I have to take strictly positive number. And the fourth one is 0. Again, I am not taking into account. So I have to close this bracket and calculate the minimum of these two. So this comes out to be 4. So minimum value comes out to be 4. But at which index the 4 value is coming? It is coming at the first index because 24 by 6. So that means, okay, that means I have to leave S1 from the basis. Okay, clear? So this gives my what? 6 as my pivot element. Okay, so now what I have to do is that, you see, since S1 is in the basis, you see this is making a column of the identity matrix. Now when X1 will come into the basis, So this will make a column of the identity matrix. So I have to create 1 at this position, and rest of the elements will be 0, which I will be creating using this pivot element. So I have to do the row operation. Okay, so what are my row operations here? Okay, so now I understand my next basis. Okay, so now my um, okay, so now my next basis will be what? B equal to what? Which variables are there? X1, S2, S3, S4. So that means I am now able to make another choice of the basis which will be actually feasible, and at the same time it will be giving me an improved value of the objective function. Now if I want to see what is the improved value of objective function, I had discussed the formula, what that Z hat. Okay, so my formula was what, like new value will be what, Z minus theta j into Zj minus Cj. And you see what is my present value? My present value is 0 here. So what will be my next value? It is 0 minus, what is theta j? Theta j is my, what, the minimum ratio 4 multiplied by Zj minus Cj. Zj minus Cj is how much? I am entering the first one. So Z1 minus C1. So this is minus 5. So this value will be equal to 20. So initially I am at present basic solution, I am having the value 0, and I am going to create a new basis with basic variables x1, s2, s3, s4 with the objective function value as 20. So I'm going to jump from 0 to 20. That means I am missing all the basic solutions, or the solutions which are having value in between 0 and 20. Okay, so that is the important point of this simplex method. Otherwise we were calculating all the basic solutions. Okay, so next I have to calculate the new basis. So
सर ये जो स्टेप है लास्ट स्टेप रिपीट कर दो प्लीज.
So what I'm saying is, now we are going to calculate a new basic solution with bases as x1, x2, s3, s4, and this basis will be giving me a solution whose objective function value will be 20. So at present my value is 0. I'm going to calculate a basic solution with the objective function value as 20, so which is a big jump. So there are basic solutions which are giving me value in between 0 and 20. I'm not going to calculate them, so I'm missing them, and I really don't require them. So that is the efficiency of this algorithm. Okay, I'm not calculating all basic solutions. So what we do, we construct our next table. So what is my next table? You see. Okay, so my variables are x1, x2, s1, s2, s3, s4, and my new basis will be what? It will be x1, because s1 is replaced by x1, s2, s3, s4. Okay, now since 6 was the pivot element, so I am dividing the whole row by 6, so I will be getting 1 here, and what I'm getting in the next is, let me check out. So next value is 4 by 6, that is 2 by 3, 1 by 6, 0, 0, 0, and 24 by 6 is my 4. So my row operations are what at this moment? That row 1 is going to what? Row 1 by 6. And how I'm applying second row operation, since I have to make this 0, so what I'm doing, how row 2 is going to change. So what you do is, so you divide row 1 by 6, this row by 6, you are getting this pivot element as 1, and then you subtract from row 2. So when you subtract row 2 minus row 1 by 6, so you will get this element as 0 element here, which I am updating in this way, and this will come out to be equal to what? 2 minus, what is this? 4 by 6, 2 minus 2 by 3, that value comes out to be equal to 4 by 3. Okay, similarly this value will come out to be equal to 0 minus 1 by 6 is minus 1 by 6, 1, 0, 0, 6 minus again 4 comes out to be equal to 2. Then I have to make this as 0. So what will be my row operation for the third row is what again? Row 1 by 6 will make my this entry as 1, and then I'm going to add in the third row. So add in the third row. So what it will be? It is 0. So 1 plus 2 by 3 will come out to be equal to 5 by 3. 0 plus 1 by 6 is 1 by 6, 0 plus 0 is 0, 1 plus 0 is 0, 0, and 1 plus 4 is my 5, and the last one is 0 because this is already 0, so I need not apply anything, so the last row remains same. So, okay, and then you calculate your CB. So for x1 you had 5, 0, 0, 0. So your new Zj minus Cj comes out to be equal to 0. So this is 10 by 3 minus 2. So what is this? 10 by 3 minus cost of x2 kitne thi 4. So this comes out to be equal to minus 2 by 3. So this value is minus 2 by 3. So this is 5 by 6 because Cj is 0. Rest of the values are 0 because they are basic variables, and otherwise also if you calculate you will get 0. And you see what is the objective function value? You multiply Cb with xb. So what is Cb into xb is 5 into 420 plus rest of the things are 0. So values as predicted here. So I got 20 value. Okay. So that means I am able to construct a basic solution with which is giving me objective function value as 20. Okay. So but can you see if this table is optimal? No. Still this table is
No,
not
sir.
optimal. Okay. So still this table is not optimal. Why? Because Zj minus Cj is because Z2 minus C2 is equal to minus 2 by 3, which is negative. So my optimality condition is not satisfied. Okay. So that means now I have to enter x2 into the basis. Okay. So if x2 is entering, which one of them is leaving? So again, I have to calculate the minimum ratio. So what is my minimum ratio? So you calculate minimum of what? 4 upon 2 by 3 means 4 into 3 by 2. Then 2 upon 3 by 2, 2 into 3 by 4, and then 5 into 3 by 5, and then 2 by 1. So you see this value is 2. So this is 6, and this is 3 by 2. This comes out to be 3. This comes out to be 2. So the minimum value is what? This is 3 by 2. So 3 by 2 value is coming at the second one. So that means my second variable is leaving the basis. Okay. So this minimum ratio is what I'm calling it as theta j. So this is basically because j is equal to 2 here, so I should say theta 2. Okay. So theta j is actually theta 2, right? Because why? Because j is 2 here. Okay. So that you can see from this thing. These indexes, again, I'm repeating that these are important to understand, because when you are writing the program, you need to understand which index you are talking about. Okay. Then again, I will be constructing my third table. So let us see what do we get. Again, you can predict your value of objective function, what it should be, because if I'm entering this into the basis, so you can see your z hat is what? Z minus theta j into zj minus cj. So present value is what? 20 minus theta j is how much? Theta j is your 3 by 2, and what is your zj minus cj is minus 2 by 3. So you cancel out, so this becomes 1. So next value will be 21. That means I'm still having an improvement. The next basic solution will be giving me an objective function value which is higher than the present one. Okay. So what are my bases then? So it will be x1, x2, s1, s2, and my CB is what? 5, 4, 0, 0. These are my basic variables: x1, x2, s1, s2, s3, s4. Okay. So because x1 is already in the basis. Okay. So let's write again the row operation. So what you are doing, you have to make this
सर यहाँ पर
element.
सर S3 सर यहाँ पर S3 S4 नहीं आएगा सर नई टेबल में x1
Yes.
x2
Oh,
S3
sorry.
S4
Yes, S3, S4. Okay, S3, S4. So again, 4 by 3 is my pivot element. So your row operation is what? Your first row 2 will go to what? Row 2 by 4 by 3 means row 2 into 3 by 4. So this element will become 1. So I'm writing this element as first. So 0, 4 by 3. Let me write down the things here. So 4 by 3. So this will come out to be equal to minus 1 by 8, right? Then you have 3 by 4, then you have 0 0, and the final entry is 3 by 2. Okay, and to make this element as 0, so what I'm going to do is I'm going to divide row 2 by 3 by 4 by 3, means I'm going to multiply row 2 by 3 by 4, and then because this entry becomes what, okay, instead of writing this, so I should write down that, so I should write down that row 2 divided by what, 4 by 3, this entry will become 1, and then you multiply with the coefficient of what, whatever coefficient is available here, you multiply it with 2 by 3. So this entry will become what, 2 by 3, and now you subtract it from row 1. You understand? So once you divide this by 4 by 3, this element will become 1, but you want 2 by 3 in order to make this 0. So you multiply with 2 by 3, so this entry will become 2 by 3, and then you subtract it from row 1. Okay, that's what we are doing. So on simplifying, what we get, it is row 1 minus 2 by 3 into 3 by 4 times row 2. So you cancel out this. So this is 1 by 2. So it is actually row 1 minus 1 by 2 times row 2. So you see, you multiply this with 1 by 2 actually. So it will become 2 by 3, and then you subtract it. Okay, but the formula is coming from this way. Okay, so what I'm getting here is, so when you apply this row operation, so I will be getting 0, 0, 1 by 4 minus 1 by 2, 0, 0, 3. Similarly for the next, this is for my row 1, and how is my row 3 is going to change? It is row 3 minus what, 5 by 3 times what, row 2 by what, 4 by 3. And again you can simplify the things and calculate. Again I'm going to write the answer, what it will come out to be, 0, 0. So this will come out to be 3 by 8 minus 5 by 4, 1, 0, 5 by 2. And similarly you can calculate the last entry, that it is row 1 by 4 by 3, and subtract from this, and you will be getting what, 0, 0, 1 by 8 minus 3 by 4, 0, 1, and the entry will come out to be equal to 1 by 3. And your row operation will be what, row 4 is what, row 4 minus row 2 divided by 4 by 3 only. Okay, again you calculate the Zj minus Cj, this comes out to be equal to 0, 0, and what is this value, 5 by 4 minus 1 by 2, so this value will come out to be equal to 3 by 4. This value comes out to be equal to 1 by 2. You again, this is minus 5 by 2 plus 3, so this will come out to be 1 by 2. These values are 0. This is my solution. And when you multiply CB with the right hand side, what is this, 5 into 3. So what is your right hand side, 5 into 3. So this is CB transpose XB is equal to 5 into 3 plus 4 into 3 by 2. So this is 2. So 3 2s are 6. 6 plus 15 is what, 21. So your Z value comes out to be equal to 21 as predicted. So, and you see all Zj minus Cj's are greater than or equal to 0. So I have my optimal solution. So that means this table depicts an optimal solution. An optimal, in fact, optimal basic feasible solution. And my algorithm terminates here. Okay, so what is my optimal solution then? You can see here. So my optimal solution again come out to be equal to what? The basic variables are 3, 3 by 2, S1 0, S2 0, S3 is 5 by 2, S4 is 1 by 2. And my objective function value is this. Z value is this. So this is my optimal. That's exactly what we obtained by the graphical method. Okay, same answer we got by the simplex method.